Design biology audit of abiogenesis, when lab chemistry isn't the same as early Earth. Hello everyone, Dr. Mason here. I will be reviewing a video I watched called How Did Life Begin? Abiogenesis. Origin of Life from Non-Living Matter by Arvin Ash. What the video is aiming to show. I hear one significant assertion in this video. Chemistry can make the parts, but life might start without magic. Then, over time and with a lot of testing, those sections can move toward the first living system. The video also conveys something that matters. Evolution is not the same as abiogenesis. Abiogenesis is about the beginning of life. Evolution is about how things change after life has already started. That difference is correct and valuable. The video also makes a big point. It states that we don't have a complete, step-by-step plan for creating the first cell that can copy itself. That honesty is the nicest thing about the video. It is also the most critical warning indicator because the video closes with a lot of confidence. What the video does well. The video does a good job of explaining lipid membranes. The heads of lipids prefer water, while their tails don't. They often form spheres when they sit in water. That bit is genuine chemistry, and it is true. The video also displays significant advances in the study of the origins of life. In lab reactions, scientists can make amino acids. In regulated environments, scientists can make vesicles and fatty acids. In some situations, scientists can get short RNA-like chains. The video doesn't say we have proof yet. It adds that the entire road remains a mystery. That is a fair thing to say. The video also fights against a wrong point of view. It doesn't support the assumption that a modern bacterium must appear all at once. If life began on its own, it probably started simpler than cells do now. That makes sense. Where the video is weak, there isn't just one fact that is missing. There is a pattern in the weak point. The film says that success in the lab is a strong sign of success on Earth. It goes from can happen to did happen. I check that slide. I ask a simple query when the film explains that building blocks form organically. Where naturally? Of course, in a lab setup that keeps things safe, or naturally on early Earth, when things are diluted and destroyed. Researchers in a lab often choose clean inputs. They are in charge of energy. They employ setups that keep products alive long enough to measure them. Chemistry would not be pure on the early Earth. It would be a combination. It would be open. A lot of things would break down what just happened. The main question is not if molecules can come together. The main question is whether they can build up, stay around, and work together to make a workable system in real life. The video is based on these ideas. The video first assumes that producing a molecule means making enough of it. A few molecules in a lab flask don't fix the problem of how concentrated the early Earth was. The oceans of the past were vast. Dilution is not kind. A pathway can be real and still not work at scale. Second, the video implies a net gain without showing one. You can make amino acids and break them down swiftly. If destruction equals formation, nothing gets built up. If the system can't keep what it makes, time doesn't help. Third, the movie assumes that the conditions are the same at each phase. The video does talk about an actual fight. Salts can disrupt lipid vesicles, while specific RNA chemistry requires ions. That is a fantastic thing to say. But that's just one fight. A lot of steps go in different ways. Water helps move things around, but it also breaks down polymers. Heat can speed up reactions, but it can also break things. Some reactions can occur with UV light, but it also kills much of the organic matter. Compatibility is not the main difficulty with the systems in the video. Fourth, the video presupposes that selectivity shows up. Chemistry makes things that mix. Life needs a small number of molecules in particular shapes. The movie doesn't explain why life employs amino acids and carbohydrates in one-handed form. The movie doesn't explain how random polymers don't turn into basically meaningless sequences either. Fifth, the video thinks that integration is a detail that will happen in the future. It says we have three sections: lipids, proteins, and RNA are all types of molecules. But the first live system needs more than elements all in the same position. It needs to be coordinated. It needs a container that gets bigger and smaller. It needs heredity that copies with high accuracy. It needs a catalyst that helps with copying and keeping things up to date. It needs an energy link to keep the system running. The video says that this level of integration is not yet complete, but it still sells a solid case. The deep time rescue doesn't fill the gap. The video uses a lot of big numbers. It talks about millions of years of trials and trillions of them. That sounds convincing, but it only works if every trial has a real potential to make progress and keep it. More trials don't help if the environment destroys gains as quickly as it makes them. Big numbers don't fix problems like dilution, breakdown, incompatibility, selectivity, and integration. They make whatever actual road already exists more of it. Deep time won't remove the halt if the path has a hard stop. Coded life is not the same as thermodynamics. The video also uses thermodynamic principles to explain how energy moves and breaks down. Patterns can form when energy flows. Crystals are made by nature. Vortices are created by nature. Convection cells are made by nature. Those are actual instances of self-organization. But a living system is not just ordered. It is also specified. It stores instructions and duplicates them. It uses that information to build and sustain itself. The jump can't be explained by energy flow alone. The video doesn't show how energy loss can be turned into programmed heredity. A straightforward approach to make the video better. If I were rewriting this video to make it tougher to argue against, I would make the word natural more straightforward. Every time I would keep the lab natural and the early Earth natural apart. I would also move the story's main point. I'd put integration at the top. I would explain out loud that manufacturing parts is not the same as building a system that can replicate itself. Then I would ask for the missing proof. I would ask for experiments that look at how net accumulation changes when things are destroyed. I want mixed chemical exams instead of clean inputs. I prefer open system tests to protected traps. I would like to see examples that show how copying leads to the expansion and division of containers. I would still celebrate the lab's success. I would stop saying that they are close to solving the core problem. This is what I think about the video. The video is straightforward to understand. It demonstrates real research. It also lets in the main gap, but it softly fills that void with confidence. I draw a line between what the video shows and what it presupposes. The movie shows that chemistry may create some building blocks under certain conditions. The film posits that the blocks can build up, remain alive, remain compatible, become selective, and form the first self-replicating system on early Earth. The last section is the valid claim. That element has not yet been proven. Thanks for watching. Please like, comment, and share this video.